Welcome to another episode of our Conservation Talks podcast.
Glad to be here.
Today we're doing a deep dive into, well, the really paradoxical world of metals. I mean, think about it. Strong enough to shape entire civilizations, right? But also fragile enough that just air and moisture can cause decay.
It's a fundamental contradiction, really.
So our mission today for this deep dive is to give you a kind of shortcut to being well-informed about metals, their enduring nature, but also, how delicate they are.
Yeah, we'll look at what they are, why they deteriorate.
And then get into the ethics and the methods, some cutting-edge stuff for their conservation.
Exactly. It's a fascinating field. So metals, fundamentally, they're elements. Things like gold, silver, copper, iron found in the earth.
Right, in their raw state.
Correct.
Yeah.
But it's human skill, often using fire,
Yeah.
that transforms them into the materials we actually use.
And then we started combining them.
That was the real game changer. Alloys. Think bronze, that's copper and tin. Brass, which is copper and zinc. And of course, steel, iron plus carbon.
These alloys, they weren't just materials, were they? They, propelled progress.
Absolutely. Tools, art, buildings, incredible strength, incredible beauty. They were the backbone.
Okay, so they built our world.
Hey,
But you said earlier, paradox, the chemistry that makes them strong.
is also, the source of their decline. It contains the seeds of their own destruction, so to speak.
Wow. That's quite the built-in vulnerability. What does that actually mean for, say, an old metal statue or tool?
Well, it means we face this silent enemy, deterioration,
Corrosion.
corrosion.
Yeah.
At a basic chemical level,
Yeah.
metals want to return to their original, more stable ore state. That drive, that process is corrosion.
And what kicks it off? What makes it worse?
The big culprits are usually humidity in the air, salts maybe from handling or the environment, and pollutants. They act like catalysts, speeding up those unwanted reactions.
And we definitely see the results, like iron rusting. Everyone knows that reddish, flaky stuff.
Right, and it swells, it causes cracking, really undermines the structure.
But it's not just rust, is it? I've heard of bronze disease. Sounds nasty.
It can be. It's typically this green, powdery corrosion, and the worrying thing is it can spread aggressively if not treated.
Okay, and silver, that just gets dark.
That's
Yeah.
tarnish, usually caused by sulfur compounds in the air. Gold, on the other hand, is famously resistant.
Ah, so gold is safe.
Mostly. Pure gold, yes. But if it's alloyed with less noble metals, even gold can suffer some corrosion on those other components.
So, given this constant threat, how do conservators actually protect our metal heritage? What's the first step?
The first line of defense is always preventive conservation. It's all about controlling the environment,
How so?
mainly keeping humidity low. Often the goal is below 40% relative humidity, using sealed display cases or storage containers, maybe with silica gel packets to absorb moisture. Inert materials for storage, too.
And handling. I always see curators wearing gloves.
Crucial. That avoids transferring salts and oils from our skin, which are surprisingly corrosive over time.
Okay, so prevention first. But what if corrosion is already active? What then?
That's when conservators have to intervene directly. It might involve really careful mechanical cleaning using tiny brushes, maybe scalpels under magnification.
Delicate work.
Very. Or using chemical stabilizers to slow down those damaging reactions, and sometimes more advanced methods are needed.
Like what?
Things like electrolytic reduction. It uses a controlled electrical current, often in a special bath, to gently reverse the corrosion process right at the molecular level. It's quite amazing, but needs specialized labs.
Wow. And after cleaning or stabilizing.
Applying a protective coating is usually essential. Traditionally, that meant waxes or lacquers.
But we have newer options now.
Oh, yes. We've moved towards advanced polymers, even nanocoatings, that can form these incredibly thin, almost invisible barrier films to keep the environment out.
Speaking of advanced methods, I hear a lot about a green revolution in conservation. What's that about with metals?
That's a really exciting area. We're talking about green inhibitors. These are substances designed to stop corrosion, but they're biodegradable, non-toxic, free of heavy metals,
Where do they come from?
often from natural sources. Plant extracts, amino acids, sometimes even specific microorganisms or biopolymers. It's a big shift from traditional inhibitors like, say, benzotriazole, BTA.
BTA.
Yeah, BTA has been used for ages, especially on copper alloys, but it has some environmental and health concerns. So the push is towards safer alternatives.
Interesting. So it's not just about being eco-friendly, it's a whole new approach.
Wow.
How do these green things actually work?
Well, there are a few ways. Many work by forming a very thin film on the metal surface they absorb onto it, physically or chemically sticking, creating a barrier.
Like a tiny shield.
Sorta, yeah. Others might help the metal itself form a more stable protective layer that's called passivation. Or they might precipitate out, basically removing the aggressive corrosive stuff from the vicinity of the metal.
Sounds promising. Are there challenges?
Oh, definitely. It's still an active research area. We need to ensure they're reversible, a key principle in conservation. Sometimes they can cause slight visual changes, like a graying effect on the metal surface.
Ah, okay.
And reproducibility can be tricky because being derived from natural sources, their exact composition can vary depending on how they're extracted. So lots of potential, but still work to be done before routine application everywhere.
It seems like even with the best inhibitors or coatings, green or not, how you put them on matters a lot. I've heard this referred to as the madness of method.
Absolutely. It's a critical point that's often overlooked. There's a surprising lack of standardized procedures across the field for just applying the coating.
Really? So different conservators might do it differently.
Exactly. And things like the coating thickness, how many layers you apply, and crucially, the drying time, both between layers if you apply more than one, and the final curing time, these factors significantly impact how well that coating actually protects the metal.
Drying time seems simple, but it's that critical.
Hugely critical. If it doesn't dry properly, or maybe the temperature's too high during application or drying, you can get something called dewetting.
Dewetting? What's that? Does the coating pull back?
Precisely. The polymer coating can sort of retract on the surface, forming tiny gaps, almost like bubbles or craters. And those exposed spots completely compromise the protection.
Ah, I see. So a tiny flaw in application can undo all the work.
It can. Longer, properly controlled drying times generally lead to a more stable, uniform, and effective protective film. It just highlights the precision needed.
All this careful science, the coatings, the cleaning, it brings us to a really fundamental question, doesn't it? An ethical one, maybe aesthetic too.
Which is?
Should old metal objects shine? Should we polish them back to how they might have looked originally, bright and gleaming? Or should we preserve the patina?
Ah, the patina question. That layer that builds up over time, showing age, history, use.
Exactly. It's a visible record of authenticity, isn't it? But maybe not what the original artist or maker intended?
It's a constant balancing act for conservators. There's no single right answer. You have to weigh the aesthetic appeal, the historical information held in the patina, the object's structural stability, and the long-term preservation goals.
So polishing might look good, but erase history.
It could erase centuries of the object's life story, yes. But preserving a very heavy or unstable patina might hide original details, or even contribute to further deterioration in some cases. It requires careful judgment in every single case.
So wrapping this up, what's the big picture from this deep dive?
I think it underscores that dual nature. Metals are incredibly powerful, foundational materials, yet they're also inherently delicate, constantly interacting with their environment.
And they've survived for ages, but that survival isn't guaranteed. It takes really thoughtful, scientifically informed,
and ethically guided conservation to ensure they continue to tell their stories long into the future.
Right. It seems the true value isn't just in the initial object, but maybe also in this ongoing human effort, the science and ethics, to understand and protect its evolving story.
Well put. It's a continuous process of learning and adapting our approaches.
So maybe the next time you see an ancient bronze or a piece of old silver, think about the hidden complexity, the science, the debates, and the ongoing research that helps keep it with us.
It adds another layer of appreciation, I think.
Absolutely. Well, thank you for joining us on this deep dive.
My pleasure.